Hi friends, welcome to our channel. Let's have a look at problem 3880, minimum absolute difference between two values. This is an easy problem, but it demonstrates some important thoughts in coding. So basically we are given an array consisting of numbers 0, 1, and 2. A pair of indices, let's say ij, is called valid if nums I equals 1 and nums j equals 2. And then we want to return the minimum absolute difference between ij among all valid pairs. If no valid pair exists, we're going to return -1. So if you look at the two examples, in the first one, you're going to return 2. So here, one is 0, 3. 0, 3, the one is 1, the other is 2. And the other is index 5 and 3. So you get a 2. So here, there are some important observations. So here, a valid pair is index. So here, it indicates that the first number is 1 and the second number is 2. However, the absolute difference is computed using absolute value. And therefore, together, the effect is that we just need to have a pair of indices. So one is corresponding to 1 and the other corresponding to 2. The order is not important. Then you just need to get the minimum index difference. So here by difference, we mean absolute value, right? So here the constraints determines the problem size. The length is bounded above by 100. So if we do a double loop, so it's O(n) squared, it's less, so it's because of the small size, so still doable. For example, there's a solution, right? You get the indices corresponding to 1, and you get the indices corresponding to 2, and then you do a validity check, and then you are going to do a for loop, double loop, they are going to pass. Let me verify this. So here I just write pass. So you see it will pass. However, it's not the best code, the most time efficient one. So the time efficient one or linear one is the one we're going to present. So here the main idea is that the mean distance must be achieved at neighboring indices, with one corresponding to 1 and the other corresponding to 2. Then we are going to use linear algorithm to address that. So for this, let's go ahead and in between, we're going to explain the logic. So first, I'm going to do some initial set. Last one and last 2 is not set yet, so we're going to make it -1. So also because we are going to compute the mean distance, I'm going to set mean distance. Let's say the mean distance to be float infinity, because we are going to call the mean function in between, right? Then we just need to do a for loop. So for I num in enumerate nums. Then we are going to check the current number. If num equals 1, so the nearest one we have seen is last one. We're going to update it to be I, right? Then if last 2 does not equal to -1, in other words, so we have a 2 which is nearest to the last one seen. So what we're going to do, the mean dist is going to be updated from the current one and the difference of the 2, that is last one minus last 2, right? Because we are computing absolute value, the order does not matter. So this is the one case. Another case is last 2. So here, let's else if num equals 2. So here it's not a negative one, it's 1, right? So if it's 2, so then last 2 will be I. Then if last 1 is not a -1, so then we have found the previous nearest last 1. So we are going to update it again. So actually we just need to copy this none. Right. So then what we want to do, otherwise in all the other cases we do nothing, right? So we just need to return the min dist. If min dist is less than or not equal to float infinity. Otherwise, we are going to return a -1. So let's first do a test. Yeah, it passes the 2 test cases. So now let's look at the generic case. Yeah, it passes all the cases. I guess for this problem, so here, this observation, the mean distance must be achieved at neighboring indices, one corresponding to 1 and the other corresponding to 2. So this caught the essence of the problem. Then you see in the if block and in the else block, we just do a check, and this is a set and this is a check, right? This is the set, this is the check, then update the distance. That's it, right? So it's rather straightforward to see the time complexity for this one is linear. By linear, we means O of n, where n is the length of nums, because essentially we just need to scan the list itself. With that said, I guess that's it for the current problem. Thank you for watching.